Hello guys, so welcome and welcome back to the channel. So we are still on the basic level series on exploratory data analysis. So in this particular video we are going to do the summary statistics. So these are the basics math to understand the data set that you are using. Probably the data set that you are using needs some more of the summary statistics. So I'm going to take you through the basics summary statistics. So for the summary statistics, you need to understand that the summary provides the mean characteristics of a data set. So basically it gets to give you the insights into the central tendency of the data, that is the mean, median and mode. We have the dispersion, that's how the data is being dispersed. We have the standard deviation, variance, the range, we have the interquartile range. Then we go ahead and do the shape distribution of the numerical values in a data set. That is the skewness, kurtosis. So for that, pandas can help us achieve this just using one function, basically to get the basic summary statistics of the data set. And Pandas has a very beautiful function that is called describe that will help you generate the summary statistics for numerical columns in the data frame. And basically, that's what we are going to basically go ahead and do as our first simple step in this video. So, using the data frame that was previously preloaded, we are going to use the describe function on data frame. So, data frame dot describe. And as you can see, it's giving us the count, mean, standard deviation, minimum. We have the percentiles and the maximum. So basically it gives us all of that for each and every column. So let's deal with the individual column. So data frame. So we are going to deal with individual column, that is the revenue total. Then we can get the summary statistics of that column. And it's that basically simple as that. You can get the mean, the count. These are the number of rows, and we have the mean. Mean is the average value or the central value around which data points tend to cluster. It's like adding all the values in a column, then dividing by the count. So you get the mean. The standard deviation, for those who don't understand, is the measure of amount of variation or dispersion in a set values. So the higher you have the standard deviation, the higher you have the greater variability. So for the minimum, that's the minimum value in a column. The percentage, basically they used to measure the spread of the value at a particular percent. That is the quartile, that is the 25%, 50, like so, and so for the 50 then 75%. So the other one, max, is the maximum value in that particular column of the dataset. So we can go ahead and do some more of this, like trying to categorize it into the three categories of the statistics, like the central tendency, the dispersion, and again we can add it with the shape of the distribution. So for this, let's go with the first one here. We go to the central tendency. So for the central tendency, we have the mean. I hope each and everyone understands what's the mean means. So we can go ahead and create for the revenue total column, get the mean. So we are going to use that specific column to get the mean. So we just use this to get the mean. Then you can use just the same, get the median. Then you can still use that to get the mode. So then we can print the values. Then we can print the the values. So as you can compare the mean, as we were given 27, we have the median 30, that's the central value, we didn't have the median. And then we have the mode. The mode is the most repeated value in that column. So that's how you can get the central tendency values in a data set for a particular column in a data set. So we can go to the other one, is the dispersion. Dispersion is basically how the data is being dispersed just by using the term itself. And basically for this we can check on something called the standard deviation. So for standard deviation, it's a measure of the amount of a variation or dispersion in a set of values. So I'm not basically going to give you the details of these basic maths. I think it's the things each and every one of you has gone through. So you just need to understand how you can do it in a coding way. So to get the standard deviation, then we also need the variance of the data set of the column. Then we need the range. The range particularly here is the difference between the maximum and the minimum values in a data set or the column data set. So the other one is the interquartile. These are the percentage, the 25, 50, 75. So let's do the standard deviation. It's as simple as we did on the mean or the median. So for standard deviation, you use the std function. Variance, simple as this, VL function. For range, simple as a maximum. Then we are going to minus the minimum, simple as that. So for this, let's define that as std. Then variance, simple as that. Then we have the range. The interquartile, basically you can use the function quantile. So let's do the percentage. For that we can use let's get the column itself, then you use the function quantile. Then you are going to pass in the quantiles or the percentage of the set. So we are going to use, for 25 use 0.25, for 50th or the 50% use 0.5. So the other one is 0.75, simple as that. So then you can try to print these all values. So print division. Yeah, as you can see, the standard deviation as we were given by the describe function was 14, to confirm just that we did it okay. For the 25 it was 1530. For 25 it was 1530, this one here. So for variance, this is the value, this is the range. The range is the difference between max and minimum. Like so, and that's how you can get the dispersion values in as a summary statistics for the dataset. So the last part of it is the shape distribution. For the summary statistics, go to the last one, is the shape distribution. It's quite simple as we just did. So for the shape distribution, we can first start with the skewness, then kurtosis. So for the kurtosis is the measure of pickedness of the flatness of the distribution. So if you have a higher kurtosis, I don't know that's how it should be pronounced, but I would pronounce it as a kurtosis. So if you have a higher kurtosis, that implies that you have a sharper peak or heavier tails compared to a normal distribution. But for this, we're just getting the distribution of the values. So let's get to skewness. Then we have the kurtosis. So it's just simple as we highlighted. Using the column, you just need the function. So this is how simple Pandas made the math with Python to be simple for the data reading or the manipulation. So for the skew, you just need the function skew, and for the kurtosis, you just need the function. As the name is being pronounced, kurtosis, like so, it needs to be a function. So let's run both. We see, let's start with the, so let's print both. So let's print them. So there you have it for the skewness and the kurtosis. So that's how you do it, to get the kurtosis and the skewness or the shape distribution of the data set. But for the shape distribution, these values can be drawn, which we might do it on the visualization of data. So that's all for the summary statistics in a data set using Pandas. So thank you for watching, and see you in the next video. Thank you.